Hello, thank you everyone. Hope everyone is fine. My name is Felipe Moretti Leila. I'm the program manager of the Motion Vertical Solution. And today I'm going to explain you and show you the nice feature that we have for the vertical solutions in Motion View 2023. So the agenda that I'll be covering start with the vertical solution Motion View as an overall, right? So mainly focus on the vehicle, but in the overall, the new workflow, what we have in there. Then we're going to talk about the enhancement that we have in the vehicle library. I go to the track vehicles, the soft soil, and then a new vertical that we are providing, the machinery tool extension, and then a few other enhancements. Because we haven't had this rollout in the 22.2 and 22.3, I'm combining now these three releases together in 23, and you see I'm mentioning about which release was done where. But yeah, let's get started. So going now to the vertical solution motion view, what's the whole idea, right? So I will use the vehicle tools to explain the workflow and also to explain the vertical that we are providing anyhow. So in motion view now, we are segregating the vertical solution to the extension manager. So in the classic versions, we had the vertical tools in motion view. It was always spread around motion view. Now we centralized everything into this extension. Now we start with that in the previous release 22.3, and talking now about the vertical solution itself. If the user go to the extension manager, they will see there in the extension manager the vehicle tools loaded, added in the extension. What has to happen then is that the user has to load this vehicle tool, and then Motion View will create now a new page. Okay, this page contains a different workflow. It's a ribbon from left to right that contains all these classic old tools now organized in a smooth way so that the user can go to left to right to build the full vehicle. So we start with the library of model, selection of library. Then we have the assembly wizard that auxiliate the user to build a model. Then we have the events, the vehicle tools, then the run process and the optimize. Now, when you load the vehicle tools inside Motion View, you get not only this page inside Motion View, but we also get a folder inside the entity browser. To enable the entity browser, you can go to View, Entity Browser, and then you see this vehicle tools folder. Inside this folder, we have three other main folders, which are the components, the events, and the examples, right? Now I'm going to talk about each one of them. Start with the components, the vehicle components. We have in the version, again, 22.3, we have rebuilt the classic auto entities into this new configuration. We have basically 10 new component models, including the S-spring, the tire, the Altair driver, the rider, and so on. Now, these components, when added in Motion View, it uses now a guide bar. So you double click on any of these components, it shows a guide bar that enables you to connect the body and the points to put the model inside Motion View. It also has now a micro dialog to help to quick edit the main parameters of each one of these components and to edit the parameters of these components, these entities. Now we have the entity editor, right? That before used to be the panel. So these enhance a little bit and provide a new workflow and a new experience to the people using Motion View to build and connect these components to the vehicle models. Then we have the three different set of events, and these events are categorized by a car and small truck events and truck in general. Then we have the motorcycle events and the general events. Now, this again, it's also an enhancement of what the events that we had in the classic version. This was done completely in 2023. To add one of these events, you must have inside Motion View a full vehicle model with the Altair driver on it. So you can double click on any of these events. So because the event is automatically connected to the vehicle, you don't see a guide bar, but there is this create button that has to be hit to include the events into the model. Now, this create button, we are planning, I put an asterisk here because we are planning to remove it in the next release, make the workflow even easier to follow. But once you add the event into the model, then you see again the entity editor to enter the main parameters of these events. You also see the simulation settings, which helps already automatically enable to edit the solver settings to run the simulation without having to go in the motion view configuration to do so. Now, talking specifically about one event, which is the KNC, in 2023, we have completely rebuilt this kinematic compliance analysis for full vehicle models. Now, this KNC event uh, supports any real vehicle in the simulation. So that means that you can now include a motorcycle, cars, trucks, any type of vehicle. Basically, the event recognizes the number of auto tires that is in there in the model and adds the post below it to proceed to the analysis. Now, if you have already experienced using the KNC analysis before in the classic, you understand that the KNC is a small set of analyses combined together into a 90-second simulation. What we have done in 2023 was to group all these analyses into a location, which is this event where the user can select which analysis to run. So with that, you can have a custom KNC report and custom KNC analysis being performed. One important notice to do here is that in the 2023 release specifically, the automate report that's generated when you perform the KNC event are only support for the full vehicle model with 4 wheels and 2 axles. Although it work if you select a half car suspension or motorcycle or truck, the report today would only be there for the 4-wheel vehicle, and that of course will be enhanced in the next releases. Another tool that's very needed is that what happens if the user has a classic model, a old model, and open the new interface. So basically, we include this update model icon button that translate automatically all the legacy events and the legacy auto entities into this new configuration. So basically, the user can open the old model, click on this button, all the events will be translated to the new one, use the entity editor, and the auto entities will be translated to the new one as well. So with everything new, every workflow will be already included, and it should be started from there, right? Talking now about the example models, we also have this folder on the vehicle tools extension that consists of a series of example models that can just be double click and that will be enabled in motion view to be run, to be enter an event or simulated. Now in 2023, we included 2 new models. One is this UTV, and the other one is this tracked armor personnel courier vehicle, which is for the ones that recognize tank model, military vehicle. It's the M113 model. We include these 2 new models to support, new off-road configuration, suspensions, or in this case of the track model, the new track that we have also implemented that I'm going to discuss next. All right, so talking about the enhancements that we have done for the library of models itself. Now, as I mentioned to you, you can go in the assembly wizard and select different configuration to build your full vehicle, right? So one of these selection consists on the definition of the differential for the four-wheel drive vehicles. So we have then included in 2022.2 a new differential model, a center differential model that can be assessed here on the driveline system. Okay, we already had before in the previous release a transfer case, but the difference between the transfer case and the new center differential is that the transfer case before was represented using a force to do the visco coupling, while now the new differential model is just a coupler where it's easier to define the differential ratio instead of being having to compute the force necessary to represent the differential model. Again, talking about differential, we also included the possibility here for the car and the heavy truck libraries the ability to lock the differential. So actually, we are including a limited slip differential system that is a force entity that has this equation as the base. So we have a lock state on that to switch on and off the differential locking system. Then we have a damping factor, which can be representative as the clutch system that is there in the limited slip differential. And based on the difference speed between the left and right tire, we can lock the differential model. And here's an example, right? So you see in this right lower corner here, a vehicle that contains a force that's pulling the vehicle. Actually, this is a test, perform a drawbar pull force test. And here we have a vehicle on a soft soil road. So you can see that although this force is increasing, there is a high slip on the tires, the wheels keep spinning at the same velocity. That's because we are using here this locking differential model, okay, that was not there before. Okay, now talking about a little bit about powertrain. We have in the vehicle library a IC engine powertrain that was present for front wheel drive and rear wheel drive vehicles. Now we include this in 22.2. We include this in the four wheel drive vehicle as well. So this can be selected here under the powertrain. Now this IC engine, it does not use an external control. It's a logic implemented inside motion. So there is a control state equation and basically represent an IC engine and a clutch system that connects to the gearbox. Now this gearbox is a manual type. And thinking about that, we include in 2023 a new feature, which is the automatic transmission powertrain. Okay. Now this automatic transmission powertrain also works for car and the small truck library. Here, the user can select this and it uses the Altair Twin Activate group into a FMU inside Motion View. And it consists on basically on the IC engine. There is a torque converter with a lockup clutch. There is the gearbox already implemented in the model, and most important, the shift logic that determines the automatic transmission. So this is receive information from the Altair driver and send to the vehicle. And the user can just pick this implementation by accessing the powertrain option inside the library itself. Now, going to the different type of vehicle, talking about truck vehicles, we have significantly changed the way to build a truck model, and a truck model may important with soft soil in 2023. So start with the truck builder workflow for the ones who never use it. So we have the workflow consists of basically we need to have a predefined body model in motion view that consists of already the suspension system, the connecting parts, body joints, and so on. And then you can use this feature, the truck builder, to first include the rolling systems, which are these wheels and sprocket that connects to the suspension of the truck component. And then we can create the truck system itself, wrap the truck around these rolling components. Now, this is a tool inside the vehicle tools. Okay, you can see it up here on the truck builder. There are three main features, right? One is the rolling system, the other one is the truck system, and then there is a third one that's only used for soft soil case. In case you have a truck system that use a different, has a CAD that contains a different shape configuration of this track link, and you are using soft soil, there is this update track link geometry that assists you to modify the geometry to be understood on the soft soil. I'm going to talk about this a little bit later. But yeah, so this is the workflow to build a track model inside Motion View. Now, what we have done, start with the new rolling system that we are providing. We have now a double sprocket and a double wheel track link. These can be represented using Motion View primitive entities or a CAD itself. So under the rolling system, you have now the rolling system type here. And well, this was necessary. We implement this now in 23 to support a second enhancement on the track builder, which is the double pin track link. Now, what's the double pin track link? It's basically a track system where the sprocket connects to the track not through the link itself, but through a second body, a connector body, which is represented in this figure by this little link. So these sprockets are now duplicated, it's a double sprocket, right? And the contact force to rotate this system picks the connector to push and pull the track. We also have the double wheel with either that's suitable for this type of configuration. Now, we implement this double pin track link because it's the most present in the military vehicle application, and also it was a request from us to do so. Now, in the track builder panel, here is how you build, actually, here is how you build the track model. So here you select the rolling system components. And in here, there is the option to select which type of track to define in the model. So, and then we have included here the double pin. There are here the characteristics of the parameters of the double pin. This double pin track link can be used both the track and the connector using a CAD, right? Or a primitive motion view primitives. And well, this defines then the track, and then the user can just then wrap the track and then you create around the rolling components all these links. Okay, another exciting feature that we included here for the track was a modification of the soft soil interaction for the track system itself. Now, in the previous release, we have released the Altair soft soil model for tire applications. And now we are providing the same soft soil configuration for the track. In the track builder now, that before was a very complex feature to add, now it's a very simple thing. So under the soil interaction, there will be a single location where you can specify the Altair soft soil model, which is basically a road file rdf.rdf, and a reference marker to specify where the soil is positioned in the model. If you have then, as I started before, if you have then the soft soil and you have a track link that consists of a different Grauser shape, we also modify this update track link geometry, including different pictures and a better workflow here to auxiliate the user to identify which parameter represents what in the track link itself, right? Now, because we are talking about soft soil, let me go to this exciting then feature about soft soil. Now, as I mentioned before, we had this Altair soft soil solution for the tire application, and here in this 23 version, we combine with the track application. Now we have a unified road file, unified soft soil model that consists on this very simple RDF database or the FDF file, RDF file, that contains basically the road parameters, which are basically the dimension of the road, length, width. Then we have the soft soil parameters. These soft soil parameters are basically the ones necessary to perform the mathematical equation using the Beck-Wong formulation of the semi-empirical model that we developed inside Altair. And then we have the tire soft soil properties, a very small one, and then the track soft soil properties. And if the user, in case the user has advanced parameters measure, there is this advanced optional and advanced track options that you can uncomment and include in the model. Okay, now to use these with the track build and the tire is super simple because we have the RDF, the soft soil road file, and then that can be automatically easily included inside the auto tire or the track builder as I showed before, that single option. And only doing that, you can already simulate the event. So it's very simple. And in case the user does not have access to Beaver meter to measure the road data, we are providing inside the installation a library of soft soil files that consist of dry sand, and then heavy clay and so on. Now, this library contains also obstacles, different configuration of obstacles that can be used to understand how it is done inside the road file. Now, also in we start in 22.2.3, sorry, but we finalize in 2023, is the ability to visualize the formable soft soil road inside HyperView, right? So we have this combined road file. We have now the support for tire and track solution. What we need is the ability to visualize these. So if you take the same soft soil RDF file and load it in the road tools, this file that you had, you now be import inside motion view, and you can visualize the different obstacles that you have, or in case you have a CRG soft soil road, you'll be able to visualize the road in motion view. Now, when you perform the simulation, this same road will be deformed, and then you can post-process in HyperView and visualize, the sinkage contour or the stress or plastic sinkage, elastic sinkage, shear stress, and normal stress on the road itself. Here's an example on the right side that you have a pickup truck on a CRG of soft soil road, and lower you have a new track model, also in a soft soil that is represented with obstacle. Here we have a big rectangular shape and then a sinusoidal obstacle. And then you can see the plastic sinkage for both animations. Now, I mentioned that we started developing this 22.3, and in 22.3, we had this separated H3D file to load in HyperView. Now in 2023, that's not needed anymore. The same results file that you have H3D for the model is the same for the road, so you just have to load it once. Now talking about obstacle, we have these several type of obstacles to be included in the soft soil. These are basically geometrical obstacles. That means a ramp, a trapezoidal, or rectangular, as you can see in this picture here. What we have done in 2023 is the ability for the user to include a custom obstacle, an obstacle of any random shape that the user wants. So basically, if the user has a shape, a CAD model, they can go in HyperMesh, create a FEM file of it, and create a PCD road. Then inside the soft soil RDF file, you can just enter this block, a custom obstacle, linking to this RDF or this random shape. So I have done that, and here you see the road in motion view. So you see the two random obstacle defined in HyperMesh in here in motion view, and then here there is the simulation of it. So here's the example model that we create, the tank model, going over these random obstacles. So these obstacle deforms like the other one, and can also be rigid, and it can also support different type of material, right? Okay, now I also mentioned before that we have combined the Altair soft soil model with tire and track. And here's a nice animation that illustrates that. That means that, okay, not only the tire and track, we can also run both together. So in this animation, you see the UTV vehicle overturning the tank model, the track vehicle, and you can see the tire with the multi-pass effect over the track path. And then in the right side, you see the sinkage due to the track system. Here you see the effect of the grousers on the track and also the tire. And here the sinkage plot by the influence of the tire passing over the track solution. All right. Now, change the subject of this presentation. I'm going to talk now about the different vertical that we are providing in 2023, which is the machinery tools or the machinery tools extension. Now, the machinery tools extension is consists of a library of gears and bearings that can be downloaded in the marketplace and included in Motion View, installed in Motion View through the extension manager. So basically, as in the vehicle tools extension, you can include this here. The difference that the vehicle tools is automatically added by Motion View. The machinery tools has to be downloaded from the marketplace. We are going to upload it there as soon as 23 is out. And then once you download it, you can add this extension. Then you see a new extension. You can load this extension. And once you load the extension, it will not create a page like the vehicle tools in this case, but it will create a folder in the entity browser that can be enabled again in the view entity browser that contains three main folders, right? One is the bearing library, the other one is the gear library, and then we have the example library. Talking about the bearings library, right? The bearings library, we provide 4 different types of bearings. Okay, that includes the cylindrical roller bearing, tapered roller bearing. Then we have the deep groove ball bearing, the angular contact ball bearing. These bearings use motion solve contacts. In case of ball bearings, we are using the Hertzian approach for the point contact that makes the simulation run really fast. And in case of the roller bearing, we have this pound green formula, which also is a line contact type that makes the simulation run really fast. And the user can, well, add this to represent any mechanism. They include bearings, and it's very easy to use. And I'm going to talk more about this in a bit. Now, another bearing type that we have is a journal bearing that we include in the library. Now, this journal bearing instead use analytical forces based on the hydrodynamic lubrication theory. We have these three theories that includes on the model, and we are providing both alignment and misaligned journal bearing. The difference that the misalignment accounts for the tilting and axial misalignment. And here you see an animation of a crankshaft that contains these journal bearing. You see here the load coming from the actuation of it. Now, the other set of library to have is the gear library. So we have basically three set of models. In the machinery tools extension, you see basically two. That's because the helical gear set can be internal and external. And to do that, you can just define a negative ratio. By doing that, you become an internal gear set. And then we have this helical gear set and the planetary gear set. Now, what's nice about this feature is that the user doesn't need to care about the mesh or the CAD or the geometry of the gears. Basically, by a set of parameters that is there in the machinery tools, right, for the gear set, the user can specify parameters such as the helix angle or the dimension of the gears, and this gear is created in the solver level. So when you run the simulation, Motion Solve, you create the gear, compute the teeth and so on, and mesh it, and then you'll be able to visualize this. What's the benefit of this machinery in this case? That if you wanna perform studies on different gear size, you don't need to bother to come back to the CAD model or HyperMesh or the software to just keep creating mesh, keep creating teeth and modifying the geometry. That can be done automatically by just changing a few parameters. Now, how these machinery tools work? What's the workflow? So like in the vehicle tools, vehicle components, we double click on that, and then it shows a guide bar that helps connecting the bodies and the entities that are needed to assemble it. We also have a micro dialog that auxiliates to quick editing the parameters, and also in the entity editor, you can view the full parameters and modify it as required. Now, these machinery are built on top of MSolve, which is the Python interface of Motion Solve. And because of that, you don't see the gears or the bearings inside Motion View. In Motion View, we have a simplified representation of the gears and the bearings. You'll be able to visualize the created gear and the bearings when you run the simulation, open it in HyperView. Now, because this process works on the solver level, it's recommended that you run the simulation using the offline simulation. And of course, this is MSolve based, so it should be Python. So you have to select the Python solver type. To do the post-processing, that can be done automatically, can be done as you are used to in HyperView and HyperGraph to visualize it. Now, inside the machinery library, we are also providing two examples. One is the reduction gearbox that contains different type of gear set and also bearings, just to understand how it is done, visualize parameters. But we also have a real model, which is a win-to-bind gearbox that contains realistic parameters and application and data. Now, talking quickly about other enhancements that we have done in the previous release, we have improved the performance of the road tools itself. So before, when you use load a RDF inside the road tools, it creates a OBJ, which is very heavy and so on. It creates a H3D that's light and is increase a lot the performance to generate, and we use this road in the model. And we also update the tire codes. For example, Siemens we upgrade to 2212, and the Cossin F tire we upgrade to 22.4. All right, that reached the end of this presentation. I thank you very much for the attention.